Hi, I'm Carter,
I'm Sydney.
I'm Lil.
and today we're going to be demonstrating how to make bootstrap confidence intervals in R for both a single means and a difference in means.
So for the single mean, that's just the mean of white wine that we're going to be using. And the question is, what is the 95% confidence interval for the mean acidity level of white wine? And for the difference in means, this is the mean difference of white and red wine. And the question is, what is the 95% confidence interval for the mean difference in acidity level of red and white wine? So that we could also say how much more acidic is red wine than white wine on average. So for some context, wine acidity plays a key role in how the wine feels on the tongue. The greater the acidity, the more crisp, but lower acidity will feel smoother. And our fixed acidity is measuring tartaric acid in the wine using grams per liter. And this is an organic acid present mainly in grapes, but also in bananas and citrus. So tartaric acid is used in cream of tartar and baking powder. And so apple cider vinegar has 0.68 grams per liter and orange juice has 0.409 grams per liter. And we don't include other items in this that are known to have acid, such as Coke, because they don't have significant levels of tartaric acid, which is what we're looking at. So
now we can get into the exploratory analysis. So first we have to get our data, which we found online. So we have it being pulled in as red wine and white wine. So we have two separate data sets. And then just to kind of look at what we're dealing with, we can do the box plot of both of them. So number one here is looking at the white wine, and number two is looking at the red wine. So based on this box plot, we can see that we're expecting red wine to have more fixed acidity, so more tartaric acid than white wine, and then also be more spread out compared to white wine. So then we can look at the summary just to get some idea of where these box plot quantile lines are. So for our white wine, the median is about 6.8. First quantile is 6.3. The third is 7.3. And then red wine, it'll have a bigger spread from 7.1 to 9.2 because we saw that the box plot was more spread out and bigger. And then just to see all of the different columns that we have within each data set, they're both the same. So for white wine and red wine, we have all of these different markers that our data set measured. So for us, we're focusing on fixed acidity, which again is measuring tartaric acid specifically.
Yeah, so now that we have our wine acidity data entered, we can look at our loop for the single mean, which is looking at white wine fixed acidity. Just getting into the code, we start with set.seed as 1, 2, 3, 4. This just makes our data replicable so we can repeat it and get the randomly populated data each time be the same. We made vector sample size, which is the length of our white wine fixed acidity, our number of entries in fixed acidity for white wine. We have vector m. We just have this be a big number, 10 to the 4th. This is how many bootstrap resamples that we create. We have vector my means. This is the vector that's going to be populated in the for loop. And we put a 0 in there to start so that if it returns 0 at the end of this, we know that it did not populate correctly. So I'm getting into the for loop. We have vector my samp. So this just takes a sample from our white wine fixed acidity, the size being sample size, how many entries in white wine fixed acidity. And then we have replacement in there. So some entries might be included 0 times, while others may be included possibly 2 or 3 times. We have this example here. You can see that 4 is included twice, but 3 is not included at all.
Sorry, I don't know why that, okay, there we go.
Yeah. And then now we have my samp, we take the mean of my samp, and then that gets populated over and over as the I ticker keeps going up. It populates my means. And then once we have all that data and all that resamples, we can look at the histogram.
yes.
Once it runs.
So it's important to know, once we see the histogram here, that we do have a normal histogram. And this is because once we bootstrap the data, and we use the central limit theorem to converge the data to a normal distribution. So you can take data of any kind, and once you use the central limit theorem, it converges the data to a normal distribution.
So as our sample size increases, the sample distribution will converge to this normal distribution that we see here. And then it's also important to note that this is very important because it allows us to take data that's super skewed and messy and make it normal, and then do a lot of more advanced statistical analyses with it that would otherwise be very difficult.
Yeah. So then we also looking at the quantile of my means. So quantile, we're looking at, we chose our confidence interval of 95%. So we make our bounds on our quantile, which is 2.5 and 97.5%, giving 2.5% on each of the tails, giving us the middle 95% confidence interval.
Yeah, so then what the confidence interval numbers are actually measuring are these lines right here, which are going to be the mean that we calculated. So it'll be this mean of my SAMP that are those boundaries of what contains 2.5% in each tail and what contains that 95% in the middle. So for this particular example, our 2.5% boundary is this 6.83, and then our 97.5% boundary is 6.87, which again is the mean of our resample, or our bootstrap resample vector. So then I just copy and pasted it down here. So then based on this, our conclusion is that we can say we're 95% confident that the true mean acidity of white wine is between 6.83 and 6.88 grams per liter. And then it's important to note that these are very, very close, as you can see, and that's simply because we have a very large sample size, which was right up here. We have sample size of almost 5,000. So because we have such a large sample, we're fairly confident that we're going to be able to accurately show the true acidity within that. Therefore, we can have a tighter confidence interval because we're more confident that it will show the true mean acidity of white wine.
Yeah, so now getting into the difference in means, we use a double mean both red and white wine. Same thing as before, we have a set seed, making our data replicable. We have now two vectors, red sample size and white sample size, which are the lengths of their fixed acidities. We have m being the same, 10 to the fourth, how many bootstrap resamples that we create. My means, the vector that gets populated in the for loop. And then we have the for loop. So in this for loop, this time we have two means, being red samp and white samp. They sample from their respective.
They're not quite means yet, too.
Yes. Good
yes.
They're resamples, samples of both red wine and their white wine fixed acidities, both with replacement as well. Mm-hmm. And once we have those samples, we then take the mean of them and subtract them from one another to get the difference in means.
Mm-hmm. Yeah, and then we also don't care whether or not the lengths are the same because we're doing the mean first. So when we do the subtraction, it doesn't matter whether or not red had more or white had more, and also they're only being sampled from within their own data set too. So they're not being jumbled all around. Yeah. So then the same ticker counts up and produces this histogram.
So this histogram is a difference in means. So it's important to note that the numbers on the bottom are differences, unlike the last one. And like I said before, we use the CLT to get the data to converge to a normal distribution.
And then we can look at what our console popped out for our quantile boundaries, and then I just copy and pasted that information right here. So for our 2.5% boundary, we have the difference of red and white mean acidity as 1.38, and then the upper bound as 1.55. So we can say from this, we're 95% confident that the true mean difference in acidity for red and white wine is between 1.38 and 1.56 grams per liter. Or another way we could say this is we're 95% confident that on average, red wine is 1.38 to 1.56 grams per liter more acidic than white wine. Again, we're measuring this in tartaric acid. So then something else that we can do with the Bootstrap, we can do different types of statistical analyses. So we can also do a ratio, find a ratio. So if we run this, it will show us the ratio between the mean of the red samp and the mean of white samp. So once it runs it, again, it has that normal histogram, which we want to check for. And then in our console, we get these numbers, which I have copied right here. So this is saying that the ratio quantities within our Bootstrap, the 2.5% boundary is 1.201, and our upper is 1.23. So this allows us to say that we're 95% confident that the real mean of red wine acidity is 20.1% to 22.7% more than the real mean of white wine acidity. So this is just another way to look at that same data and get it in a different type of context that might make more sense to some.
So just to summarize what we did, we took 2 data sets and compared their box plots. We then took one data set, which was the white wine, and did a Bootstrap confidence interval to find the true interval of mean acidity with a 95% confidence level. We then wanted to see how red and white wine acidities compared, so we took both data sets and did a Bootstrap confidence interval to find the true mean difference interval with a 95% confidence level.
Yeah, and then just lastly, we did that ratio as well. So that is how we bootstrapped confidence intervals in R.